Well, just a final comment perhaps on adding and rationalizing. These are two things that teachers will want you to do fairly often. One is to add two numbers that have radicals in them, and the other would be to look at rationalizing the denominator. So just very quickly, the notion of adding is you need to add apples and oranges. So this is something to keep in mind, that if I have the square root of 3 and I want to add this to the fifth root of 3, I kind of can't. They're really asking very different questions. So this is literally just what it is. It's square root of 3 plus the fifth root of 3. On the other hand, if I had the third root of 7 plus the third root of 7, I can add those because they are the same thing. It's like adding two apples. So that's going to be equal to 2 times the third root of 7. Alright, now often we would like to add two numbers together, and again it's a little tricky if I have, say, maybe 1 over the square root of 2 and I'm trying to add this to the square root of 2. A little hard to do that because they're really not the same thing. So your teachers will ask you to rationalize the denominator, and this allows you to begin to think about the potential to add numbers together. So if I want to rationalize, what it means to do is get rid of the irrationals. And I can do that by multiplying the square root of 2 times the square root of 2 on the denominator. And to be fair, I need to do that in the numerator as well. So I'll have the square root of 2 over the square root of 2 times this original number, 1 over the square root of 2. And I'll leave this happy fellow all by itself. Now, the square root of 2 times the square root of 2 is going to be 2. So that's going to give me really 1/2. The 2 is in the denominator. So that's going to give me 1/2 times the square root of 2 plus the square root of 2. And now I can add these together because really I have 1 and a half, or rather 3/2 of the square root of 2. So by rationalizing the denominator, I can in fact add radicals that would appear as though I cannot add them. And this is the general idea. If you have 1 over the cube root of 7, then you can multiply through to unirrationalize the denominator. And there's lots of practice coming ahead with that. But this is just a little note about things you can and cannot do and ways to get around a couple of problems. One thing you'll notice with adding is that they're often quite disguised, so be wary of that. Sometimes they may not look quite the same. So if you wanted to sneak a 2 back in here, for example, you could put a 2 on the outside, and that would look pretty nice. But really the 2 could have been on the inside. It would have been 2 cubed. So this might have looked like 8 times 7, or sorry, that's a cube root, or the cube root of 56, and you were trying to add that to the cube root of 7, and you would have noticed that they would have looked very different. But if you work backwards, you can see really that it was 2, the cube root of 7. You'll see a few of those in your problems as you go, and this is really just a warning to the wise, and we'll have videos on these both in the future, so look for them. All right. Good luck with all the assignments you have, and do drop us a note if we can make more videos for any particular problems you have. Cheers!